All right, so tonight's topic is planning and analysis of reliability demonstration tests. And our speaker is Karen Hulting. Karen Hulting is a statistician, coach, and teacher across 30 plus years in the medical device and automotive industries. She has applied a broad range of statistical methods in manufacturing, R&D, and quality. Karen holds master's and PhD degrees in statistics from Iowa State University and an undergraduate degree in mathematics from St. Olaf College. She is a fellow of the ASQ and an adjunct instructor in the St. Cloud State University Graduate Program in Medical Technology Quality in Plymouth, Minnesota. All right, Karen, I will give the floor to you. Again, thank you for joining us tonight.
Happy to be here. I will go, let's see, when you are done sharing, I will then share my screen. Let me go grab that. Okay, we'll get all the screens kind of in a way that I can see them. Move this. Ooh. Let's see if I move this down so I'm looking at the right place. That'll work. Okay. So the topic let me get this. That's what I meant to do. Let me get it to, there we go. One more screen to move around. And certainly let me know if anything is not showing up correctly. So the topic tonight, in talking with Hillary about topic for tonight, this topic of reliability came up, and my message tonight comes from work that I did in a reliability department in a business of Medtronic device manufacturer, where we had several sort of teachable moments about reliability analysis, where it turned from, I'd had a CRE certification for a while, and my reliability knowledge went from sort of book knowledge to, wow, this really makes a difference. And so some of what I'm going to present tonight comes from that experience. And so it's focused on, a relatively narrow part of reliability engineering, the reliability demonstration tests. So what kind of data do we collect, and then how do we analyze that data, and why does it matter? And I can tell you, it really does matter. The way we collect that data and the kind of data that we collect really makes a difference. Whether it's a medical device application or an automotive application, we tend to do these kinds of analysis in places where it really matters to people's safety and their lives. So what we're going to get started with, there we go. What I want to talk about is just what is a reliability demonstration test? How might we, there's probably a number of ways to plan that test, but I want to tell you some kind of key facts about planning that test. We're going to analyze somewhat coded real data. It is real world application data that comes from one of these applications, but suitably coded to present publicly. And so hopefully you'll come out of this better prepared to prove these reliability requirements. So sort of understand what reliability requirements are. I mean, chances are there are folks in this room who've been doing reliability engineering for a while and doing this kind of work. Hopefully, whatever level of experience people are in this room, you will pick up at least a tip or two for doing this kind of work in the future. Hopefully that will apply to folks who are brand new to reliability engineering, as well as people who've been doing it for a long time, really interested in having a question and answer at the end of this as well. So what I'm going to talk about, I've got this slide here kind of gives you the final analysis graphs that at this point don't mean a lot to us, both in Minitab statistical analysis and JMP. And so what I'm going to talk about first is sort of some reliability strategy and kind of how I think about reliability requirements. And I've kind of I'm calling this product that we're talking about NewCath. It's a catheter product that's used in a medical device application. And, this is the new model. And let's say we're doing some analysis, some early on characterization work. assessing whether or not we're meeting the reliability requirement, and then possibly making some updates. So we're going to talk about step-by-step planning and analysis for this reliability demonstration test. We're going to kind of go in detail. What does it look like in either one of these software programs? Hopefully that will give you confidence that if you're using yet a third statistical analysis program, you'll be able to find this kind of analysis there as well. And then hopefully I'll end in time that we'll have plenty of time for Q&A. If you have questions along the way that kind of impact quick hit kinds of questions, certainly don't hesitate to jump in. You know, I respond pretty well to even verbal questions, you know, especially if it's something that kind of helps everybody understand. If you think I've sort of left something out, feel free. I don't think this is terribly formal. So first of all, in the topic of reliability strategy, a key thing about reliability strategy is setting goals. And so what we want to do is take some inputs into setting those reliability goals. So we might call them reliability design targets. Different companies are going to call these different things, and they're going to fit into the sort of R&D process, I think, in different ways. But I think it's good if they're based on predicate product data analysis, right? If you've got a new catheter and you had an old catheter and you kind of know how well that worked for the customer, how well it met the customer and reliability requirements, that kind of analysis comes into what kind of expectations you can have, how you might improve. Some system reliability allocation, right? This catheter might be part of a larger system. And so some system reliability allocation may have been done that sort of sets a requirement for what this piece of the system has got to achieve, right? We need to have high reliability in all the components in order for the overall system to be highly reliable. It's good to set these reliability goals with a confidence level. We don't want to just luck out and estimate our reliability and then hope that that actually happens. We want to do our reliability analysis with a certain level of statistical confidence. And so you want to state that with the goal as well. So also looking into the reliability goals, we need to, kind of understand how long this product ought to last. We also need to understand that we want to do reliability testing of the clinical procedure, right? How is this product going to be used in a clinical or patient setting? If it's a medical device, if it's an automotive device, what is the sort of use case relevant manner, right? We need to figure out how are we going to use this product, whatever that happens to be. And then the format of that reliability goal is that we want to set, it needs to be X% reliable, right? Let's hope that that's a number that starts with a 9 for X amount of time or cycles or any other kind of time horizon variable with X% confidence under X use conditions, right? So each of those X's needs to be filled in. So for example, it might be 95% reliable for the case that I'm saying here for it's going to turn out to be 2.5 cycles using this catheter. So 2.5 complete cycles of the use of this catheter. That is accounting for occasionally you're going to need to use the catheter more than once. A lot of times it's going to be only once. With X% confidence, so different companies have a different standard, maybe 95% confidence, maybe 90% confidence, different standards might be used. And then that use condition topic there, X holds a lot, right? So specific kinds of use conditions. And that would, that's not going to be just one word. That might be pages of use conditions that we need to account for when we do this testing. Probably the main recommendation I have that comes from experience is that we want to, as much as possible, do cycles to failure testing, meaning we want to, and in this case that we're talking about here, This is actually a disposable medical product, right? It's not a capital equipment kind of product. And so we can take advantage of this short use cycle, and we can run this catheter through all of its use, kind of a clinically relevant set of use cycles, over and over and over and over again until it fails. Now, we have to have a fair amount of patience to do that. Oftentimes, there's kind of pushback saying, well, we only need it to last for a couple cycles. Let's just test a whole bunch of them to 2 cycles and show that almost all of them meet that 2-cycle requirement. But what's really valuable about testing these, particularly disposable products, particularly short cycle time products, to their failure point, is that we can find out, we may be very confident that they last more than a couple cycles, but it's really good to know specifically how many cycles would they last, and even more important, when they fail, how do they fail? So what you can then do with that data is you can use that to do a life data analysis in any of these statistical software, and then you can estimate with this variables data of how many cycles that all of these units lasted, estimate the 95% lower confidence bound on, say, the 5th percentile of the failure distribution. So you can know where that failure distribution starts and then compare that to your reliability goal. In contrast, what is sometimes perceived to be an easier test is decide what the sample size would be in order to show that have 95% confidence, for example, that 95% of the population will last that required number of cycles. And so then just test them to that number of cycles. If they make it, then you've got a passing observation. That doesn't give you don't find out where, at what point they fail or how they fail. And so we're kind of talking about the difference between, for example, running 59 complete devices to 2 cycles without failure. That might be perceived as a really simple test, and it is. I might be advocating for taking 15 devices all the way to failure. And of course, what troubles folks is that taking 15 devices all the way to failure, you don't necessarily know how long that's going to take. And so that introduces some uncertainty into a development program, but I would advocate for the fact that it's really worthwhile. The key advantage is that you're going to get this variables data estimate, but even more important is that you gain knowledge about the failure mode. So, if I'm lucky enough to convince a development team to take all 15 devices to their failure point, chances are I'm going to see more than one failure mode. I might see a failure mode that I didn't know could happen. And much better to find that out in the lab than to find out that failure mode in the field. And I will tell you, the reason I'm passionate about this point is I once was involved in a situation where we had a failure mode. It wasn't terribly dangerous, but it was a surprise to us. And I sort of felt at that time that it was our responsibility to not be surprised by failure modes, right? Whether they were high risk or low risk, it taught me that the next time it might have been a high risk failure mode. And I want to be able to test these products in the lab in a way that causes me to at least know what those failure modes are, to understand their risk, and then be able to, if we know about those failure modes, maybe we can mitigate for them, maybe we can redesign to design those out. There is a question in the chat, I see, differentiating between reliability test approaches for disposable versus multi-use. I would say the main difference is that it can be more difficult to fund more expensive, longer use products. All of the same topics sort of happen, it's just in the case where we've got disposable products, I feel like we sort of have no excuse. for not doing this cycles to failure testing. It can be more difficult to get all the way to failure with a full device when it is say a capital equipment kind of device. In that case, what I would recommend is doing this cycles to failure testing component by component, right? We might be able to do something like that. In all cases, the more cycles to failure testing we can do, I think the better. But I've found that, every business I've worked in, there's sort of a different sort of situation for where are our trickiest demonstration test planning situations. So maybe in the question and answer, we can talk about more specifics on that. Okay, so let's imagine that I'm going to set out to do this planning and analysis for my new calf product. So I'm going to go find my standard operating procedures, right? I'm going to find the clinical operating procedures. I'm going to find my inspection procedures. Within my clinical procedures, I might also get some information about how might this product fail, right? What might be the failure? What kinds of criteria might I have? We're going to talk about in this one, there are electrical failures, there are mechanical failures. So I might find different kinds of things that I need to inspect as I cycle my catheters over and over, or whatever this product might be. In the case of this example, let's just imagine, like I said before, that we usually use this device once, but from the clinically astute people that are on our team tell us that occasionally this device might be used a couple times. And so a decision was made that the reliability requirement would be at a 2.5 cycle point. That would give enough, of course, we're not going to use it for a half a cycle, but on average, if we can aim for reliability estimation at 2.5 clinical cycles, that clinical cycles we're going to talk about in a bit is whatever it takes to go from beginning to end in that clinical procedure with this catheter. And so we had some characterization data. We had some characterization and what we might call pre-verification data. So we grabbed all of that data. We had only 21 catheters that were tested. Imagine that 12 actually got to their failure point and 9 got to a suspension point without failure. The numbers of failures ranged in this kind of coded data. We've got failures that range from 2 cycles all the way out to 8. So none of them failed before a single cycle. That, of course, would, we'd have to really think about that. But all of these failure points were beyond the typical use case of 1 cycle. And now we have to sort of figure out, is this a strong enough product for the use case that we're talking about? You'll notice here, this shows you we're going to go through this analysis in great detail, but this is the probability plot for that number of cycles data. And so we have this plot here. This is all Minitab probability plot and estimate life data analysis. And so I can tell you right here, no need to worry about a spoiler, that if I want to estimate that 5th percentile, the best guess estimate is a little over 2 cycles, this number here, 2.165. And if I apply that 95% lower confidence bound, that 5th percentile point is only 1.4 cycles. So we're kind of going to talk about how we get to this estimate. And not surprisingly, that estimate is a little low, right? So by doing this work up front, we've discovered that we need to make some design changes in order to raise that reliability performance. So what is the step-by-step to get to that point where we have that analysis that we just looked at? So first we have to define what is one nominal clinical procedure, right? What is that test method? What do we need to replicate? Sometimes this is called stacked stress, where you figure out all the things that's going to happen to that product through one clinically relevant procedure, put that together into a test method where you're sort of doing a test method that's trying to reflect that clinical procedure. We need to figure out any kind of failure that any customer would notice. Now, this is mostly, in this case, it's going to be medical professionals. The folks using the catheter would be the people who would be noticing any kind of failure, whether it's an electrical or mechanical kind of failure. But anybody who's using that product, we'd want to be viewing it from their perspective. Define the requirement. I've said already for this case that we're talking about, the clinically knowledgeable people said that we need to have this catheter reliably last basically halfway between 2 and 3 cycles. So we're calling that 2.5. We want to plan a test to do this kind of work, figure out what sample size and how long the test needs to continue. And then we're going to do this reliability data analysis. I'm going to demonstrate it in both, what it looks like in both Minitab and in JUMP. I find that those are the two software that are used the most. There's other ones, but hopefully this will kind of show you what it looks like. So that clinical procedure, I think I might have actually said all of this. We've got to have that clinical knowledge on the team. It's really important to have people who have been in the setting where your product is being used, whether it's an automotive product, whether it's a aerospace product, or whether it's a medical device product. You need to have people who really understand. I've also got experience where we found out after the fact when, we had a unexpected outcome in early use of the product. We really didn't understand. The folks on that team hadn't really understood. We thought we understood, and it turned out once we had some surprising results and then reached out to some other folks that there was broader knowledge that was needed. So bringing folks in that really understand those use conditions of whatever your product is. I use the term clinical knowledge because this is a device sort of application. We also need to really understand, and this is where those folks who have that on the ground experience in the clinical setting, sometimes, we've got some instructions that are handed out with these catheters, and those instructions end up on the floor, right? Those instructions aren't necessarily followed. People are, have procedures for the way that they use these devices. And we need to really understand in what ways might they use it in a way that we didn't intend, but once it's out in the world, we can't exactly control. So we really need to understand what are those intended ways that the product, we might call it misuse, and that's just the way they use that product. And most of the time it works fine, but we need to really understand that when we develop our cycles to failure testing to understand how that might be used. I mentioned before, any kind of failure that as we do this cycles testing, we want to inspect. Ideally, after each cycle of use, we'd like to inspect to see if there's any kind of mechanical failure, different kinds of electrical failures. While we're using it, maybe there can be an electrical issue that we observe. And then maybe between cycles, we do some electrical testing where we might understand whether or not something has changed in that product. So we want to think very broadly. You could probably put more bullet items here that might talk about other kinds of failure criteria. That's where you're getting these knowledgeable folks about that clinical setting, and then knowledgeable about the requirements for that device. What kinds of systems do we need to check to see if it's still operating as we do this cycles to failure testing? Okay, so one of my favorite slides here is talking about planning sample size. So a really important thing, anytime you're planning sample size, you need to know what is that sample size for? Right? What kind of analysis are you going to do with that sample size? And so what I'm saying here is that we are planning for a parametric life data analysis, right? We want to use variables data. We want to use a statistical distribution, that might be Weibull, log normal, other kind of parametric distributions to demonstrate conformance with that reliability goal. For example, we might want to use that cycles to failure data to demonstrate that we have at least 95% reliability with 95% confidence at that required number of cycles. And so what you might do is estimate the 95% lower confidence bound on the 5th percentile and show that that value is higher than 2.5. So that's the analysis that we hope to carry out. Now, most of the time when I talk about sample size, I have a very specific way to plan a sample size. And I will tell you that for this situation, I have a different kind of advice. And the advice that I most often give out right now, and this of course depends a little bit on, or more than a little bit, on the specifics of your product. So the numbers that I'm saying here might not apply completely broadly, but not a bad idea to try to talk a project team into starting at least 15 units on test. Why 15? It's sort of a minimal number to have an idea of what that distribution shape might be. Now, I would love it if I could talk folks into 30 or 45 or some larger number of tests. But I find in this area of cycles to failure testing, it is a hard enough sell already. And so I'm going to be pretty happy if I can talk folks into double digits, right? At least 15 samples. And then the next thing that I need to negotiate is how soon can this test be curtailed, right? When can we give up? If we're trying to test these units to failure, I would love, my best case there on the bottom of this slide is, I would love it if we could cycle all 15 units all the way until they fail. Now that might take a lot of time because we have intentionally designed a product here that should not fail, right? We don't want it to fail soon, and maybe it could last to 100 cycles, right? That strikes fear in the heart of program managers. But if I could get all those 15 units all the way to the failure point, that is great data. What I've learned is that there are sometimes cases where I'm pretty lucky if I can get that number all the way up to 4, right? To say we need to be patient until at least 4 of these 15 samples have failed. Now, this advice, in my statistician life, this is pretty rare. Usually we have a much more specific sample size planning situation in cycles to failure testing. And you may find that you're in a different world than I have been living in, but a lot of times these tests take a long time and they are expensive. So I've learned to be pretty happy with at least 15 units on test. Ideally, they all get tested to failure, but if at least 4 of them, right? My sort of bottom line is get at least 4 of them to actually fail. It's so much better than 0, right? Because in a lot of cases, what I'm working with is we've had a history of taking a large number of units to a very small number of cycles. And I'm trying to change that around, take a smaller number of units to a large number of cycles so that we can observe those failure modes. Now, what you can do in this case, I probably should have added it to this slide. What you can do in this case is try to guess, what does that data look like, right? If I have my at least 15 that go on test, I can use the analysis methods to kind of, I can create a data set, right? It's not a very big data set. When do I think how many cycles do I think those 15 units are going to last to? At what point am I going to do that curtailment or censoring? That's something I forgot to mention. Another recommendation is to at least take all of these units. If you can't get everything all the way to failure, at least take them to something like 4 or 5 times the requirement. Now, again, that's a little bit arbitrary, but in this case, we insisted that these catheters be taken to at least 10 cycles, so 4 times that use case. These are somewhat rule of thumb kind of suggestions. And like I say, it's not really in my nature to have these suggestions that are, not exactly computed, but I find in this transition to getting folks to doing cycles to failure testing, if you're in a mode where folks have not been doing that testing, this is pretty good. Now, I know there are industries where there's a lot more cycles to failure testing that's already done. If you're in that industry, I would love to chat with you and figure out what the next step is from there, right? So this, yeah, I don't want you to fall back to this practice if you're already beyond it, more cycles to failure testing. But if you are in a situation where you're doing a lot of demonstration testing where you take it just to the requirement, say to 2 cycles, and then stop, this I think would be an improvement, potentially. Okay, so what if we get that data? So I took some real data and kind of moved it around a little bit. And just imagine that I'm combining together 2 sets of data. Sometimes I'm going to have to do that to try to get the most information that I could get on this cycles to failure testing. So if we look at this data set that I've illustrated here, imagine that I had 15. Somebody, imagine that somebody listened to this recommendation and they did some characterization work early on where we had 15 units. And we took them at least either to failure or to 10 cycles. And so we have different kinds of failure modes, either electrical or mechanical. And what we were really focused on in this work was not the mechanical failures. What we were trying to improve was the electrical performance. So it turns out that we're going to treat the mechanical failures as a censoring, as well as the ones that got all the way to 10 cycles with no failure at all. Those are also censored observations. So we're really focused on that electrical failure. And so what we're going to do with this data, all we need, I'm actually not using this grouping variable. We had some characterization data, some pre-design verification data, put these 15 plus 6 observations together into one big data set. I've got cycles. It's a little hard to tell. The cycles data is over here on the right-hand side of that column, and then the failure type is on the left-hand side. So they're a little close. But we've got all the information we need to do this reliability data analysis. So we're first going to take a look at it in Minitab. And so in Minitab, you would go to the reliability and survival mode, and there's a distribution analysis with right censoring. Now, right censoring means that we've censored the observation at a certain point, and if we could have run that test longer, the real failure point is to the right. If you're imagining a number line going from left to right, the real observation, if we could have seen it, would have been to the right of the censoring point. That's what right censoring means. And so in Minitab, what this looks like, if we wanted to try to figure out, use this data set, it's a pretty rich data set here. We got 21 data points, some of them censored, to figure out what distribution might fit this data. And so I did this analysis trying Weibull, log normal, exponential, and normal. Now you could certainly try some other possibilities. We have to tell Minitab that there's a censoring column and what that censoring value is. And if we do that, then we get this distribution identification plot where we get a probability plot for each of those 4 distributions. Now, when you look at them, they don't look all that different. Exponential looks quite a bit different. What we're really suffering from here is that the cycles to failure data, because it's a small number of cycles that the failures are occurring pretty quickly, which is kind of a spoiler alert. They're failing too quickly. They kind of stack up, right? So it's really discrete kind of data that we are fitting down here. And so when you've got a whole bunch of failures at the 3rd cycle, those are going to stack up, and it's never going to fit that straight line just perfectly. So, this is another case where I'm such a fan of cycles to failure testing that I'm, in the medical device industry, engineers know about fitting distributions more than any other industry I've ever worked on, because we actually have auditors ask us, how is your distribution fit to your data analysis? And so what we're looking for in these 4 graphs is we'd like to see the blue points lining up along that red line. We notice that we only have a blue dot for the 12 units, the 12 observations of an actual failure point. The other 9 observations a lot of them, we've sort of reserved, the analysis reserves some space kind of on the right-hand end of that probability plot for the ones that would fail beyond 10 cycles, right? So these dots, they don't kind of follow the whole number line or that probability plot line, because some of them aren't actually failure times, and they're accounted for in this reliability data analysis. So, you know, we want the dots to kind of fall along the line. That kind of leaves us with everything but exponential, right? Exponential fits only here in this kind of middle range. And since we're mostly concerned with the early failure times, we're going to kind of focus more on the left-hand end of this, this analysis. We can look at these Anderson-Darling tests that Minitab gives us. We want the smallest, you know, kind of minimize that Anderson-Darling statistic. They're all essentially the same number, right? There's hardly any difference between these Anderson-Darling statistics. And so in looking at this, I would conclude that the log normal model fits the best for my purposes, because it fits well on that lower tail. And then it kind of goes through the rest of the data points. So I'm relatively happy with that log normal fit. You could also do something where you do the analysis in, you know, choose a couple of these, right? Maybe log normal and normal. Now, log normal has the great advantage is that it's not negative, right? If I chose this normal distribution model, we see this line over here at the bottom. Hopefully you can see my cursor on this shared screen. It actually predicts some negative cycles, right? Which is not very appealing in a model. So for many reasons, I would go with that log normal model. And then what we can do is use that distribution model. We go into a part of Minitab where here, I need to move my control so that I can see. We go into parametric distribution analysis in a similar area in the Minitab software. I'm doing an analysis on that cycles variable. I need to tell Minitab, like I did for the distribution analysis, what my censoring information is, so it knows which are actual failure times and which are censored observations. The only thing that I changed in this estimate, you know, we've got a whole bunch of things, a lot of options we can set in this analysis. I'm going to go into the estimate. It's going to default to maximum likelihood estimation, which a lot of studies show is the, you know, when in doubt, use maximum likelihood. And then I added in, I want to estimate my reliability at the 2.5 cycle point. And so I'm going to put that in to this analysis step. And then I'm going to say that I want to use 95% confidence. I'm going to be estimating survival probabilities, which is a synonym for reliability, right? I'm going to estimate reliability or survival rather than failure probabilities. And so then I want to have a lower 95% confidence bound on that survival probability. How low might that reliability be? And so if I add, let's see, got to click on there. So when I do that, then I get this analysis where I estimate this 95% lower bound on the percentiles. And so we can kind of see that on this graph. I can go to my 5% line over here on the graph and kind of run it over to see that that lower bound intersects the 5th percentile line somewhere between 1 and 2 cycles. The estimated, you know, the best guess for my 5th percentile is a little bit over 2 cycles. And then we can see the actual numbers over here. The 5th percentile is just over 2 cycles, which is somewhat optimistic because then we look at that 95% norm, the confidence bound relies on a normal distribution assumption. We are using a log normal assumption for the time to failure data, but that confidence or the variability around that fitted line, that uses typically a normal distribution assumption. And then we get to this estimate of about 1.4 cycles is what we can count on with 95% confidence. Now, since we set our reliability goal to be 2.5 cycles with 95% confidence, this number is not adequate, right? It says we could luck out and maybe last for that over 2 cycles, but we can't be confident of that at that 95% level. Okay. So then what happened in this real life example, you know, like I said, suitably changed a little bit here, because that was not an adequate reliability result. Luckily, we were early on enough in that development program that some work was done with the physics and the design options in that product, and we were able to make a new and improved new calf, and take that out and do some additional testing. Now, in this case, you'll see in this frequency column for my new set of data, it adds up to 15. So 15 units were put on test, and only 2 of them failed, right? We took them to 10 cycles. I'm pretty sure, yes, 10, yes, suspended at 10, that's right. So I didn't get quite what I wanted, right? I'd like to see 4 of these fail, but you know, 2 is better than 1, which is better than 0, right? So the more we get, and we also saw many of those failure modes because we had, what was it, 12 of them that failed in their early testing. So we have seen the failure modes. And so in this demonstration test, it was, you know, in this negotiation of how we're trying to do this cycles to failure testing, I was glad to see it, to take this data to at least 2 failures. And we were able to do that by doing the suspension at 10 cycles. So 12 of those units now made it to that 10 cycles. 1 of them failed right on the 10th cycle. 1 of them failed for a mechanical reason at 7 cycles, so we were no longer able to really look at the electrical situation, and 1 of them did have an electrical failure at the 8th cycle. So now we redo that same exact analysis. Now it's really tricky to check distribution, right? Because we only have 2 failure points, so we're not really checking. We're going to just use the same distribution that we used before. We're going to use that log normal distribution. We find that our estimated 5th percentile is over almost 9 cycles. And then with that very consistent results that we saw, then our lower bound is at 7.3. So a huge improvement in the reliability performance of this product. You know, this kind of close to real, but a little bit coded product that we're talking about here. Now, one thing I want to point out is this lower confidence bound. We have a fairly narrow confidence band down here at this early part of that failure distribution. But because we didn't take enough of these all the way to failure, we don't really know what's going on out there. You know, at 15 cycles, that confidence bound is really wide. And at a certain point, we just really know nothing. So there is an impact of having all of those suspensions. But we do, because we've improved this product so much, we have a precision at the area where we need to make that conclusion. Okay, so what would this same exact analysis look like in JUMP software? I'm a fan of both programs. They're both really great. I put the same data set into JUMP. You enter that data a little bit differently. You need to say which is the Y variable that you're analyzing in this. We go to analyze reliability and survival, and then there's a life distribution module. And so like with Minitab, we need to say what is the time metric, and then what is the censoring information, and what is my censoring code. So very, very simple. We do get kind of an interesting graph. I'm a big fan of this event plot. And in this event plot, I should have put in here the key, but you can sort of visually see, here's all my censored observations. This is this first set of 21 actual failures. So each one of these X's, we had 12 failures. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each one of these kind of almost looks like a little insect, sort of. That is an actual failure time. All of these kind of open arrows say that at that point, it's kind of trying to illustrate that the failure is off to the right of that point, and that we see where the censoring points were of course, these that happened before 10 cycles, those are the ones that failed for a different reason than we were focused on in this analysis. And then we had a whole bunch that were taken off test here at 10. So that's kind of a nice graph to make it really visual about how that the kind of the structure of that data. And then we have a similar sort of probability plot here where instead of having the non-linear X or Y axis here, we've got kind of a curve illustrating that log normal fit to that same data. That looks kind of familiar from the mini tab. Now, in both cases, there are a lot of adjustments you can make to how these graphs appear. I'm sort of demonstrating here the most, kind of the most default appearance of all of these analyses. There's a whole lot that you can do in both Minitab and in JMP in reliability analysis, but I kind of want to just show you kind of what it looks like in both programs. Then, like we did in Minitab, we're going to use that distribution model to compute the lower 95% confidence bound on that 5th percentile. The way that we're going to do that in JMP is under estimate. We're in the kind of right under these graphical outputs. You will have a whole bunch of statistical output. You can ask for estimating probabilities and estimating quantiles of the distribution. And so we see that if we put in the 0.05 failure probability, that's asking for that 5th percentile. There is, and it's called a quantile in JMP. There's my 2.16, the same number that we got out of Minitab, and my lower confidence bound. JMP actually gives 2 different ways to do those confidence bounds, a walled estimate and a likelihood estimate. This 1.38, the walled estimate, matches what we saw in the Minitab output. And like I say, there's many options that you can change to make these line up. Then when we make that design change and we've got our stronger data, then here's that new probability plot with our 2 dots. Again, it uses a linear scale in the probability metric, and then the line becomes a curve, either, kind of equivalent information. And then we do that same estimation work of estimating that 5th percentile or the 0.05 quantile, and we get our lower 95% confidence bound at 7.4. So showing that with our improvement in that reliability, in the design, that we get the reliability we were hoping for. Okay, so in this example and kind of talking about how the reliability goals were set, in at least in general terms. Hopefully that gives you kind of a case study of how you might be working on reliability demonstration. I've shown some rules of thumb for planning, and then very specific instructions for how to analyze that reliability demonstration data, in particular using a cycles to failure approach rather than sort of fewer units taken to more cycles rather than lots of units taken to fewer cycles. And so the example I've shown here is based on a really real world application, even though it's a little bit coded. And hopefully this causes you to be, for whatever state you arrived at this presentation in, hopefully you've gotten a little bit of a tidbit of something that helps you in your work in this kind of analysis. And so with that, I'd be happy to take any questions.
Are there any questions for Karen this evening? Thank you for your presentation. It was very informative. I enjoyed it.
Sure.
I have no questions.
That is one thing about presenting on Zoom. It's a little hard to see. I can't tell if people have got questions along the way. So I'm glad we've ended with plenty of time here to have a conversation. I'd be really happy to take this in whatever direction people would like.
Yep. Great. Thank you.
Karen, I have a question. Barbara here. When you say catheters, are you talking about the classic catheter for urine or something else?
No, this one is actually, this is, let's see, how do I say enough but not too much? It is a catheter that's working with cardiac issues. So a catheter
Okay.
gets fed into as a treatment for a cardiac problem. Yeah, that's
Okay,
a really
okay.
good question. I'm glad you asked. It's not that sort of urinary kind of catheter. This is, anything skinny that's fed through the body gets called a catheter.
Okay, so this kind of relates to all these, pacemakers and all these other things that Medtronics does for hearts.
Right. A wide range of sort of cardiac rhythm devices. And
Okay.
so it would fit into that category. Yeah.
So there's the
And
actual
it has it clearly has some mechanical requirements, and it's got electricity. It's plugged into
Right.
something, right? So it's doing some
Right.
electrical work. Yeah.
Okay, okay. So there's different ways it can fail. Yeah, exactly.
Right. Especially in difficult use, right? It's getting fed through the body, and so it has to withstand a lot of flexing and it cannot break, right? And that isn't a failure mode, right? Breaking off is not really a failure mode, but sometimes in all of that difficult use case, and it differs from person to person, there can be some unexpected needs for robustness in that product. Let's see. I'm seeing some, let's see. So I talked a little bit about disposable versus multi-use. I think I actually moved at one point into a business that had a capital equipment kind of thing. And boy, we were trying to work on reliability estimation for that. That requires a fair amount of deep thought about how, if we need to show reliability in something that's very expensive. I mean, I sometimes talk about, we're not going to test 59 airplanes, right? We do that kind of testing on these big capital equipment kinds of things, whether it's a medical product or a transportation product. Most of those we end up breaking down into smaller pieces. And then through modeling, we kind of pull together the results to have that overall system impact. But we might be applying this same approach to a subcomponent of that multi-use device. So that often is a solution. Figure out what are the critical, kind of do your requirements prioritization and figure out what are the key subcomponents, and then apply this kind of cycles to failure approach to that key subcomponent.
Okay.
Oh yeah, here we go. In general, what to do if management disagrees with the reliability analysis and says a non-medical or electronic product is fine to sell.
Oh boy.
Whew, yeah. I mean, it's I have had relatively little need to sort of really put my foot down. I find that I think a wide range of things happen when you're doing reliability analysis. More often than I would have expected, I'm trying to talk folks off the ledge from being completely risk averse, right? I'm trying to say we can quantify these risks. And if we are so risk averse, then nobody's ever going to get our product, right? I'm surprised how often I'm kind of people think the statistician's going to show up and ask for more sample size and more data and never make a decision. But because we can quantify these risks and put confidence bounds around them, I think we can really understand what we know and what we don't know. Now, so oftentimes I'm arguing for a less conservative approach because I want people to have the opportunity to have these, life-changing devices. It is true that there often is push in the other direction of who cares that it failed your test? It's only 2.1, close enough to 2.5. Let's go with it anyway. Right. And so in those cases, I find that I just have to sort of stand my ground. And oftentimes what's the most helpful is if I have a real life example where we might have made that decision and we ended up with problems that were harder to solve later, right? So a story about a difficult outcome can be really helpful in those situations. And it takes a while to get those stories, right? I mean, I've got a particular case in my head when I'm talking about how important it is to do cycles to failure testing, so you know the failure modes, because I have that case where we didn't see one failure mode coming. We truly did not imagine that it could happen. Like I say, we were lucky in that it was not a terribly risky one, but that was still very instructive to me, and I use that story in all of its detail internally. I'm still a contractor in the medical device industry, and so I still do use a suitable version of that story to kind of give people a vision of what could happen if we don't listen to the analysis that, we've got real data telling us something here that can save us from some trouble in the future.
It looks like we have another question in the chat, or a couple of them.
Yes.
Have there been any situations where you're able to compare the reliability analysis results to field results?
That is so interesting. It should be possible, shouldn't it? I know more of people telling me that we did this analysis in order to make this decision on this really painful, mitigation, painful meaning expensive mitigation that we had to follow. And then I remember hearing, not from my own analysis, but from other folks, how well the eventual long-term field performance matched up with that reliability prediction. So I don't recall a situation where the prediction has been, night and day from what really happened. I think mostly what we find where things don't match up, it's when we didn't really understand the use case, right? When we might have not understood what the typical misuse is, what we thought they were doing ABC and they were doing OPQ, right? Something, the way we thought people were using this device was not exactly how they were using it. We might have imagined that between every cycle of use, a certain flushing situation was done, and maybe, that takes too much time. All right, so that's where we really need those people who are on, right there when the product is being used to really tell us what is a clinically relevant testing procedure. Okay, let's see. Expensive equipment, greater budgetary constraints for sample sizes. What do you suggest in these situations when 15 is not feasible? Yeah, definitely anything that you can do in a subcomponent, and then a smaller number of total systems. I sort of find that it's really good to figure out, what do we really need to know? Because sometimes we're in a situation where we've got enough margin to that requirement that it doesn't take a lot of sample size to demonstrate the confidence level that we need to show. So we need to get really clear on what is needed. And that's why I say I'm almost a little uncomfortable with this kind of arbitrary, put at least 15 on test and get at least 4 of them to fail. That's not going to apply really broadly, right? That is just kind of accepting that in some cases we are in a transition from doing testing just to the minimum needed use case and then stopping, where I would like to encourage people at whatever sample size you can, take them all the way to failure. So if you're in a situation where 15 is not feasible, you might be able to tell that 10 is, or you might be able to tell that 5 is, right? Even if we take 5 units all the way to failure, that's going to be information we wouldn't know otherwise. We don't want them to go all the way to failure in the field. We want to do it a little bit in our own lab first. Let's see. Project managers, understandably, do not necessarily like to test to failure. Let's see, first phase gets sufficient. Yep. Yeah. Second, a couple phases is really good. If you can get that, like that characterization testing that we showed that, you know, I kind of in my mocked up data set there, imagine that there's some characterization tests that somebody with some foresight got started on early when you've got the time to wait, right? You kind of don't want to do your cycles to failure test the first time when you're doing your final verification work, because that's really, you know, in critical chain, you know, project management, that's going to really delay things. If the products are really highly reliable, you know, the irony is bad news comes fast and good news takes a long time to get. And so I think the person with the question here, really good point that if you can do some of that cycles to failure testing in your early testing and then use, like the case I showed here, I had more actual failures in that early testing than in the later testing, but we could benefit from that early testing to kind of inform what went later.
Okay. Do we have any more questions for Karen this evening?
Yeah,
Okay.
this is maybe kind of unrelated, but in the early stages of designing a medical device, are people typically using like FMEA analysis to think
Yes.
through all possible failure modes and the severity of them and get some kind of idea?
Yes. Yes.
Okay.
So that
Okay.
risk analysis and deciding, I should have, that's actually a really good point. I should have put that in the part with the reliability goals. You know, a huge part of all of that is a risk analysis, right? To bring in the
Okay.
risk, you know, that's going to inform what levels of reliability are needed, what levels of confidence are needed. And usually there are very specific procedures. So I've been kind of focused more on this testing part, but
Yeah,
you make a
yeah.
very good point. The risk analysis is a really big part of it, and I should probably acknowledge that in this to make sure you know, none of this work can be done separately from the risk analysis. And so the failure
Right.
modes, in addition to coming out of predicate data and all that analysis, they're also coming right out of that FMEA work. Yep, very good point.
Okay, because I kept having to preach to people about FMEAs are not torture devices. They're just ways to think through a problem.
Yes. 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 Yeah. It's not just a spreadsheet you got to fill in and stick it in a drawer. Yeah.
Right.
It's really, it's important for, and getting multiple views into that FMEA work, right? To get different perspectives. And then what you learn in this cycles to failure testing can then go back and inform that FMEA.
Right.
What if we discuss, if we take them to failure and we discover this failure mode we hadn't expected, then that can go back and inform the FMEA. Yeah, that's true. I think that's a really good point. I gotta, you know, have to write that down. As I revise this presentation for any other audience, I'll be sure to mention the risk part of it.
Okay. Anyone else have a question for Karen this evening?
I had a question following up on the requirements. Are there industry standards or regulatory standards for reliability that are expected to be demonstrated? Or like when you came up with the 2.5, is it all based on use conditions and company discretion?
Yeah, that one in particular, there wasn't any stated requirement. For certain kinds of products, there are some industry standards, or the regulators will have certain expectations. But for that case, it really depended on how that product was being used and what we defined as a clinical cycle. That clinical cycle, actually, in the case that I have in mind, it was a complex set of steps, right? One cycle was, you know, a page worth of do this, then this, then this, then this, then this, and that was the clinical cycle. So it was specific enough to that use case and that device that we probably wouldn't find something standard out there. I would say the companies sometimes will have a standard for what levels of reliability they might require for certain FMEA results, right? You go through the FMEA, and if this device or the critical performance requirements of that device have a certain risk level, that might lead to a level of reliability and might lead to a level of confidence. But I'm only aware in a few cases that there was sort of a regulatory expectation or something. A lot of times people would love it if they were given, here's what you need to meet. More often than that, especially in new product development, there might, at least in my experience, it was rare that we were given a requirement from outside.
Really? Okay.
We got a lot of feedback in audits, right? We had people asking, why this? What's your rationale for that? How do you justify this? Because it's never 100%, right? So trying to figure out what's that balance between a high enough reliability expectation, because this is people we're talking about here, right? And this is health and all of that. So we'd love it to be 100% and 100%, but trying to figure out, where is the point that we can actually demonstrate that level of reliability feasibly with this kind of product. It's always plenty expensive to do this kind of testing. We would never say, well, that's too hard to test, we won't test it, because not testing and finding out later is even more expensive. But at least I'm not, and it's possible that, I worked in a particular area. There could be other folks that could tell you a different story, that there are more regulatory requirements, but I was not aware of anything. I was rarely aware of a case where we were told, here's what you need to meet.
I had a follow-up question. You're talking about, the strong value of test to fail, and that being powerful to understand the capability. But how would you handle demonstrating or being able to detect for defect-driven fail modes, like the front part of the bathtub curve, when you're trying to assess for a product? Would you consider that a separate plan, or?
Yeah, those seem, it's interesting, because my experience has been that I'm more worried about us not taking them to large numbers of cycles, sort of the wear out failure modes are the ones that I have. I would say my School of Hard Knocks has applied more to those. Maybe the early ones, it's easier to get more of that testing in. But that is kind of interesting. I haven't seen a lack of that kind of information, where I've seen more lack of the, how does it eventually fail kind of information. So I don't, that's a very interesting question that I can't say much to, because I don't remember having, being in a position of trying to convince folks. I feel like we get that information. Maybe that happens, we find out early on if something's failing quickly. We find out quickly, and we pay a lot of attention to that. It's a little harder to know, if these failure modes happen out beyond the use case. We might not be in a habit of doing a lot of that testing, because people can argue that it doesn't matter how it fails out there, but sometimes the way it fails at 4 times the use case, something could happen that pulls that failure mode in sooner. And I'd still like to see, what does that failure mode look like, even if it's happening out beyond my current use case, because I might not understand that there's a vulnerability that causes that to happen sooner.
Right. You would like to know how close to the cliff you are, and what's the mechanism, what's the critical failure mechanism. Yeah, I've done reliability for semiconductor packaging, and so that's definitely a challenge. I was asking about the quality side, because it's challenging to make sure that you're sampling the full manufacturing distribution process window. There's not some corner that's going to have defect fail.
Right.
So-
I do find that, I forget what this other presentation I was giving. Was I teaching or something? It's so funny. Recently, I remember in this conversation, oh, I know, the Minnesota section meeting, that I was in a conversation there about sort of these nerdy assumptions behind statistical analysis. And one of those nerdy assumptions that I think probably causes problems to us more often than we recognize is the representativeness of our samples, right? We sort of get some data and we forget to assess, is this really representative of that population that we're trying to make conclusions about? Or did we just run the process one day, get our 30 samples, great sample size maybe for whatever purpose, and not realize that it hasn't really covered the whole breadth of where those products could be, or maybe not even kind of thinking through what are the, we sometimes do worst case low, worst case high, this kind of thing. But quite often, I think we don't realize that where we get fooled between our data analysis and our conclusions is recognizing that our sample size might be the right sample size, but it's not representative enough of the whole population that we need to conclude about.
And yeah, absolutely.
And that's that whole,
Right.
do we have a stable and capable process before we make these conclusions? A lot, back to the, Dr. Deming views of, we shouldn't be out here making conclusions if we've got a trending process, and maybe we don't even realize that some of this is happening. And I think that can happen in our reliability data because it's super expensive data. We have to convince somebody to give us a bunch of samples to destroy. Are those samples really representative? I think it can often be we do all this work to do all this very good work and all this very good testing, and we make some conclusions, and then we find out later that, oh, those were, on one side of that distribution or something like that.
Right.
There's going to be no end to challenges in this area.
All right, we've still got a little bit of time. Does anyone else have questions for Karen?
Question, your reliability report, it will be part of the design device history records, or is it stored somehow?
Yeah, I mean, depend, I would say I've been in different organizations that manage documenting these kinds of analyses in different ways. Sometimes they're they're part of, like you say, the design history file. They may be feeding into different parts of the quality system tasks, design verification, very often design characterization, justifying requirements, I do find that reliability requirements kind of worry folks. Are we real? We might have high aspirations for reliability, and then if we miss that reliability goal by 0.1%, what are we going to do? Are we going to not release the product? Right? Everybody seems to have a story of where we set a nice high goal and we just barely missed it. Then what? Right? Once you set a goal and you say this is the requirement, you're in kind of a tough spot regulation wise if you don't pay attention to that. But is it really practically different? That little bit of a difference, right? And so I think everybody's kind of struggled with some of those goals, and what seemed like a really attainable goal might not be, due to time, money, surprises, personnel, all kinds of reasons. And so I find that different organizations have different expectations for where these reliability goals fit into the product requirements. Is the reliability goal a requirement of the product, or is the reliability goal this other process that we do to assure quality? But the requirements are just what physically that product needs to carry out. And I've seen it done a number of different ways. I've not been really a reliability leader, somebody who's in charge of deciding how that's all going to work, but I have seen it done in different ways with pros and cons, right? Some people very much want it to be absolutely required by the quality and reliability system. And other folks, sometimes I've seen when it's absolutely required, that can have some unintended consequences. So, it's, but again, I spend more time helping people have attainable goals for reliability, because we're trying to balance this, risk and benefit, right? If we paid so much attention to the risks that we never put out a product, then a lot of people would not benefit from those products. By no means does that mean we're throwing things out the door without thinking about it, but sometimes that kind of paralysis of risk averseness, can also have some negative consequences. It's a lot to think about.
Thank you, Karen.
Yeah, good points in the chat, right? Definitely characterize. The sooner you can start getting test data, the better. Characterization data is hugely valuable. It hardly ever works great to wait to collect your data for verification, because there's almost always a surprise there.
Right. Are there any final questions for Karen? We've still got a little bit of time if you have questions on your mind. Okay.
Good.
Well,
It's been very fun.
yeah, absolutely. We've enjoyed having you.
Glad to be here.
I will reshare my screen. Okay. Oh, looks like we have another message. Is the question? No. Okay. Can you all see my screen again?
Yes.
Yep.
Okay, perfect. Okay, so now we move into our networking sessions. We have two for this evening. We have a Meet the Speaker session with Karen, if you want to get to know Karen a little bit better, maybe more on a personal level, or if you have additional questions for her regarding her presentation. And then we also have a breakout session on ideas for short courses, if I can get someone from the leadership team to volunteer for that. Otherwise, we'll just go into one big room and do a Meet the Speaker or ideas for short courses.
Well, I guess I can, this is Bob Mitchell. I can take that breakout room number 2, ideas for short courses.
Okay,
If
sounds
anybody
good.
wants to meet. But I want to thank you, Karen, again for an excellent presentation. As always, it's always good to hear from you and listen to your thoughtful words of wisdom and shared experiences.
Hope everybody heard something they hadn't heard before. I sure learned some things. So that's what's really fun to do these things, is to get some new ideas for myself and get some, sometimes it's just good to be around other folks that have other questions that you haven't heard before. So this is really great.
All right, give me just a minute to create those rooms, or I guess the one additional breakout room. Everybody who's wanting to do Meet the Speaker will just remain in the main room, and then if you are interested in joining the breakout session for the ideas for short courses, you'll select that once it pops up on your screen. Let me see.
So while Hillary gets that second breakout room set up, so for the purpose of short courses is obviously we do a monthly program meeting that's, well, an hour presentation by a guest speaker. We have other types of free webinars too, again limited to 45 to 60 minutes. But here we're looking to expand our portfolio and member value by delivering short courses of certain topics. And these typically are maybe a 2-hour session or 2-hour sessions. In the recent past, we've had a series of short courses all around the Lean Six Sigma Green Belt Toolkit, where we focused a little bit more on some of the tools that you would use as you run through the DMAIC methodology. Now we're looking for some additional thoughts. It can be more Lean Six Sigma, but it can be from entirely different realms of the traditional quality book of knowledge. So we are looking for your suggestions on what new learnings or basic refreshers you would like to have. So this would give us a little more time to delve deeper into specific topics. So if you have ideas, if you've been looking for certain types of short courses and just can't find them, this is your opportunity to join the breakout room and let us know.
Yep. All right, we'll have 5 to 10 minutes for these networking sessions. I'm going to go ahead and open the breakout room now. Again, if you are interested in joining the breakout room on the short courses, please go ahead and opt to enter that room as the prompt comes up. Otherwise, if you'd like to continue your conversation with the speaker, just remain in the current room. Okay, here we go. And then Bob, you'll have to assign yourself as well. I didn't assign you. But I can. Do you see the prompt? Oh, there we go. Okay. I'm disappearing was confirmation enough.
The joys of breakout rooms.
Yes, exactly. Oh goodness. It says we have 14 minutes, but that's not as much time as we have. So let's see. Unsigned. All right, it looks like we'll wait just another minute for people to join. Is anyone having issues with the prompt that came up on the screen? Did everyone see that prompt?
Oh, and then under the more button, if somebody missed the prompt, they can go under more and grab the join breakout room.
Okay, thank you. I always forget that.
I was just thinking, what would someone do if they missed the prompt?
Yep.
Well, I think I missed the prompt and I can't even find more.
Oh,
Oh,
interesting.
More.
Along the bottom, like next where it says, on mine, I've got AI companion and then more. I don't know what AI companion does. Does it make me smarter?
I think it just keeps record of the conversation, of the
Oh,
presentation.
really? It
Like
summarizes everything.
Summarizes it. Yes, exactly.
Yeah,
Oh, there's
ChatGPT.
breakout rooms. Yes, I see it. Oh goodness. I have been having so many weird issues with Zoom lately. It's just, oh.
Oh no. Let me just check the chat really quick.
Okay.
Are you joining the other one, Barbara, or are you staying?
I think I'm just staying in this one.
Okay.
Yeah.
All right. Well, we will continue then. Does anyone have additional questions for Karen this evening?
Karen, do you usually get involved in the whole product design process, or is it just certain areas that you end up getting involved in?
I mean, it's a little bit dependent on the role. I think at the time when I was doing more of this reliability work, I was part of the quality reliability side of new product development. So,
Okay.
you know, I'd get very involved in planning some of these demonstration tests and planning, you know, any kind of sample size thing I'd get involved in. And then whenever there was a surprise, and then we had to figure out what kind of data do we need to collect, or, you know, how do we react to the surprise? What kind of information do we need? I'd get involved there as well. I mean, to some degree, you know, and there weren't a lot of, there's a fair number of biostatisticians that are doing human clinical trials and that kind of thing in the business, and a little bit less, we sort of, you know, hand engineers their Minitab license and figure we got it covered, which is not really true, because some of these applications are really high stakes. So we want to get it really right. And so I'd get involved in those I'd often get involved when somebody might have made a promise to a regulator that we couldn't keep, right? It was a well-intentioned, you know, we'll prove X, Y, and Z, and it turns out that it's really not possible. It's literally not feasible to prove that thing that we promised. And so trying to assess that and figure out what really is the right expectation, I might get involved in that. But I would say pretty broadly when there were statistical applications that I could find out about and help out with, I'd get involved in that.
Okay. Because I was more involved with the whole process from start to finish, and just, you know, I was basically, you know, the one who got stuck with fixing the non-conformances after the audits. So I finally just invited myself to the meetings, and sometimes I said, I am not leaving this room until you sign these forms. Back when it was all paper-based.
Yes. Yeah. I mean, it does happen a little too often that if you could have been there when the original work was done, you could prevent this issue that you're now trying to, you know, do somersaults to try to fix.
Yeah.
Some early prevention can be very helpful.
Yeah. So I was just thinking about this stuff, and and it was the engineers who were generally designing all the statistical stuff, but you know, it was me more kind of walking through the process with them, and just making sure they did the steps properly.
Right. Whenever I knew about it, I was sure happy to be there, you know, kind of coaching minute to minute. Sometimes there were folks who were kind of given the impression that because they were a smart engineer, they must know all of statistics, right? And so they were, you know, I can't tell you how many conversations begin with an apology, right? Sorry, statistics is not my strong suit. And you know what I like to tell people, right? Well, yeah, what I have come to say is that I'm a smart statistician and I don't know all of chemical engineering, right? So you might be a smart chemical engineer. You wouldn't necessarily know all of statistics. Now, the trouble is I don't have to do chemical engineering typically to do my stats work, where they need to do stats to do their chemical engineering work.
Exactly.
And so it's sort of something where it's not an all or nothing. It's a tricky business. What I try to tell folks is that a really good thing for us to do is distinguish between high stakes and lower stakes. I mean, nothing's low stakes, right? None of this stuff is unimportant, but kind of identify when we're making promises to a regulator, or we're reacting to a finding and we've updated the product and now we're getting we're getting re-audited. We got to get that right? There's no, we want to not only get it right, we want to get it precisely right. And so I understand the assumptions well enough to fine tune what we need to worry about. And often I find that folks might, in that stressful situation, worry about too many assumptions that don't even matter in this case, right? Assumptions that matter for this analysis, but not that analysis. And so distinguishing if I could wave a magic wand and have sort of managers of engineering work distinguish between high stakes and moderate stakes, stats applications and find those high stakes applications and make sure we've got somebody either with a statistics, graduate degree of some kind, or at least, one line that I have sometimes used is somebody with 5 academic courses in statistics, right? They might not have a master's degree, but it's more than short courses, right? Short courses are great for learning new tips and tricks and getting better at certain things, but negotiating with an FDA inspector, you want a depth of knowledge where you sort of know stuff twice as deep as where you're operating, right? You really know that stuff. And so, it takes in the neighborhood of 5 academic courses in statistics to kind of have enough depth to really answer those questions and to be confident to say normality doesn't matter in that case, right? What the p-value is for normality has no impact on this analysis. And it's really hard for somebody with less expertise to say something doesn't matter, right? And to have that, I've had very cordial conversations with auditors where they were sure that they caught me in something, right? I remember this one sample size calculation. They were sure that there was no way somebody could justify it. And, I will say it wasn't my favorite bit of work to be able to support, but I was not making it up. I was not saying anything incorrect. I was on relatively strong footing, and the auditor was pretty sure that it wasn't at all. And so the auditor said, well, I'm going to go back and talk to the statisticians at the agency. And I thought, that is great. They will agree with me, right? This is, it sounds like this shouldn't work, but it turns out that it knowing what I know, it does work. It's, it's not an overly cautious approach, but it is a completely appropriate approach. So it is kind of interesting, with that level of expertise, what you can do in those difficult situations, but we can't staff everything, right? With that kind of level of expertise. There's a lot of day-to-day engineering work that benefits from some really good Minitab approach. Somebody who knows how to run a designed experiment, knows how to fit a model, knows how to do a gauge R&R and understand a capability analysis. All of that stuff is really important to know.
Exactly.
And might not be super high stakes, right? It might not make a really big, isn't a subject of great contention with the regulators, but it really, really helps us more effectively design products that really help people. So, it's kind of distinguishing that work that if you do your design, I might make a slightly different decision for exactly which DOE form to use. Am I going to use a fractional factorial, or how big, what's the sample size? Somebody may make a slightly different decision than I do, and it doesn't have that huge of an impact because you're still using good methods and they're pretty robust. But if you get it off that same amount in this promise you've made to a regulator, or explaining why we did certain things, that can have a much larger impact. And kind of distinguishing those different kinds of things, I think, is helpful.
Yeah.
You made the distinction, between Minitab and JMP, and I'm not familiar at all with JMP. Is JMP considered more of the gold standard for reliability design life in your
no, I mean, there are people who really love either program, right? I am not a representative of either one, and I've used both throughout my career. JMP was developed as sort of the Macintosh or personal computer version of the bigger program SAS. So SAS Institute, Statistical Analysis System, how many years ago? 30 years ago, created this program called JMP that stands for John's Macintosh Program. That's what JMP stood for in the beginning.
Interesting.
And so it was this early on kind of nimble little program. It's a wonderful statistical computing tool. It's a little, if you were handed Minitab and you're handed Jump, you get started with them a little bit differently. They kind of, their table of contents looks a little bit different, but there's a lot of things that you can do in both programs. There are folks that really love both of them and you couldn't pull either one out of their hands. I'm a little more agnostic. I think they're both great. Use either one and you will, so much better than none at all, right? So much better than rigging up your own analysis in Excel. So they're both really great programs. I think Jump may have a more some kind of more cutting edge reliability tools in it. I've seen some lately where they've got some Bayesian reliability stuff and some kind of gee whiz stuff. But for the, kind of the key reliability work, I once did a presentation that used ReliaSoft. That's a special purpose reliability software. Truth be told, a colleague of mine did the analysis in ReliaSoft because I mostly don't. And then I matched that same analysis in Minitab and that same analysis in Jump. It looks a little bit different, but you can do very similar things. So I think any of those three tools that you have, great. And you will find folks that really feel that one or the other is absolutely what you've got to have. I'm more a fan of, I love standardization. I love when whole organizations use the same tools so that everybody can talk to each other. What I really hate is to see people not giving good peer review to somebody's work who's working in a different software because they think they don't understand that analysis. It's just that it looks a little less familiar because it's in another tool. So that can be a barrier, but they're both great tools.
Great. And with that, it looks like our other breakout room is coming back in. So perfect timing. Because we had such great conversation, I did allow it to flow a little over. Instead of the 5 to 10 minute window, we were at 15 minutes. So what we are going to do is we're going to skip the report outs for tonight. I think Bob and Rob got some pretty good ideas on how to move the section forward with short courses over the next year or so. So we'll talk about those in one of our business meetings. Let's see. And Karen, as I mentioned, you are welcome to stay on for all of this. You are not required to. So, oh, you're on mute.
I'm on mute. Central time zone. I think I'm going to cut out if it's all okay with you. Really good meeting with you guys. Thank you so much.
Thank you.
Thank you. Thank you.
I'm going to check out. Thank you, Hillary and the team and Karen. It was fantastic. I don't need to know anything about the Phoenix section business, and you don't want me asking questions. So thank you guys.
Hi, Chris.
Thank
Bye-bye.
you. All right, we have just a few announcements before we tie everything up this evening. There are some announcements from ASQ as the society as a whole, and then from your Phoenix section specifically. So some events to keep in mind as you're planning your next calendar year. We have the Women in Quality Symposium, which is going to happen December 5th this year. It's a completely virtual event. It's just one day. I've attended this event in the past, and it is very good. And it's not just specific to women in quality. Men can also attend this event as well. And then the 2025 Lean in Six Sigma Conference is coming up February 23rd and 25th, or 23rd through 25th. That will be once again at the Renaissance Hotel in Glendale. And then the World Conference on Quality and Improvement is going to be held in Denver, Colorado this year, May 4th through 7th. These are your elected 2024 ASQ Phoenix section officers. I am Hillary Warner, the section chair. We have David Gibson, who I don't believe is on the call tonight. He's our secretary. And then we also have Amrish Patel, who is our treasurer. We are currently searching for some additional volunteers. We have been very fortunate in filling our slate of volunteers for next year. We're almost there, but we need just a few more. We're looking for an arrangements coordinator who is responsible for arranging on-site events. So they would be responsible for the contracts for anything that we did on-site. That includes networking events, that includes meetings if we go back to in-person meetings. They would also be responsible for getting people registered at the event. They'd be responsible for setting up for refreshments at the event, as well as the technology. And then we have a LinkedIn manager who we're looking for, who is responsible for posting information about the section to LinkedIn, whether that's past events or future events. It could be a combination of both. And then we're looking for an Instagram influencer kind of to do the same thing on Instagram. And NextGen is preferred for this particular position. This is a list of your 2024 Phoenix Section Leadership Committee. So if you're looking for any one person in particular or any position in particular, these are the people that you should be reaching out to. And then currently we have programs slated through March of next year. I believe we have everything posted to the website through February. We're just waiting on the March program to be finalized, and then we'll have all of those up on the website through March of next year. But
Okay.
beyond that, we are looking for additional individuals to present, and these presentations can be on soft skills or technical skills related to quality in any industry. Presentations should typically be about an hour long. They can be a little less or a little more. Just communicate what your needs are for your presentation, and it'll be just fine. And you can contact me currently if you have ideas for presentations that you'd like to present, or if you know someone who has presented a great presentation in the past. You can also reach out to me with their name and contact information. Upcoming networking events in 2024. We are still trying to put together a wine tasting. We've kind of hit a hiccup with this, but we're still trying to put it together. You can be on the lookout for invitations via Constant Contact. We'd also have, of course, information posted on the website as well. Let's see. If you are a Phoenix section member who is attending this meeting tonight, your name will be entered into a drawing for a section branded travel mug. And it is a stainless steel travel mug with the section brand on there. So it's good for both cold and hot beverages. Last month's winner was Omar C. So Omar, if you were on the call tonight, congratulations. I hope you received your mug in the mail. There is one mug per program meeting that is awarded, and then each section member is eligible for one mug per year, essentially. So if you've already won a mug in a calendar year, your name will not be entered back into the drawing for another mug that year, but you can win the next year. So keep attending these meetings. After we have each monthly meeting, we do send out a section survey, we do send out a survey to the section, and that survey is sent out by Bob Mitchell. This is the results. This summarizes the results of the survey from last month. We had 53 attendees and a 19% response rate to the survey. Meeting performance was 95% overall, which is great. We are improving. We do listen to your feedback, so thank you so much. For those of you who have responded to these surveys, it is greatly appreciated. We have a running 12-month average meeting performance of 89%. That too is also increasing with the meeting performance increasing. Just a couple reminders for those of you trying to navigate My ASQ. The events tab on My ASQ is where you'll find upcoming section events, including conferences and monthly programs. The job board is where you will find recent postings of available jobs. So if you are in the market for a new job or you know somebody who is, please direct them to the job board. And the library is where you'll find previous program recordings, which you can watch for RUs and email Bob Mitchell for a certificate. And just as a reminder, this year, I believe we are continuing to give 0.2 RUs for attendance at section meetings. And then next year, it'll go down to 0.1 RUs. So make sure you get your viewings in before the end of the year. And then the library is where you'll find newsletters, handouts, presentations, and mini papers if you are interested in any of that information. So this is just a reminder, we are always looking for senior members to we're always looking for people to upgrade their membership to senior membership. Your baseline ASQ professional membership is cost-effective and competitive. It does provide you with a professional networking within a global organization. It provides you with discounts on training, programs, events, conferences, and certifications. I did the math, and if you attend one conference, the amount that you save as a member attending that one conference is paid for by your membership with ASQ. So it is worth it, especially if you're attending multiple conferences and have multiple certifications. You get access to online and published content, as I showed you on my ASQ. You get updates on professional news and issues for current best practices and innovative emerging trends. And you also get to attend Phoenix section networking events, and you get discounts on those as a result of your membership. However, if you level up to a senior membership, there is no additional cost for this. And you do receive membership in one additional section, or you get a journal or magazine of your choice. It's a limited choice, but it's still an option. Criteria for senior membership include you must be an ASQ member in good standing for 1 year, and you must have 10 years of professional experience and have one of the additional following. You must have conducted quality-related work for at least 2 years, have taught quality-related classes at a college for 2 years, have been a senior member of another comparable organization, or currently hold an ASQ certification that requires certification. So it's definitely worth it if you have this experience and are able to level up to a senior membership. All right, just a few wrap-up comments. I want to remind you to please complete the event satisfaction survey. You'll find the survey link and your electronic RU certificate in the thank you email from our VOC chair, Bob Mitchell. His email address is roberthmitchell@gmail.com, so please be on the lookout for that. And then in 2024, we have a few goals in mind. We'd like to provide 12 hybrid in-person virtual meetings. Well, actually, we're providing all of our meetings hybrid this year. We want to provide one tour at a winery, brewery, or a company of the like. We're currently working on a brewery or a wine tasting at this point. This will be in person only. We did provide one community outreach event that was this past Saturday at St. Mary's Food Bank. It went extremely well, and this was, of course, in person only. And then coming up on December 12th, we do have a presentation that will be provided by Joseph Paris. This will be a recording of a previous presentation provided by him on KPIs versus OKRs. If you are looking for us on social media, you can find us on various platforms. We are on Facebook, LinkedIn, X, formerly known as Twitter, Instagram, and YouTube. So please look for us there. This is where we post all of our past events as well as our upcoming events. So if you're not actively involved on MyASQ, you'll find information about events on these social media platforms as well. Are there any final thoughts, comments, or questions this evening? I'm going to open the chat just to make sure I haven't missed any.
Well, the one thing I would like to say, it's kind of late in the day now, but happy World Quality Day.
Yay! Oh, yes.
Thursday, November 14th is recognized around the world as World Quality Day. Of Quality Month is the month of November. This entire week has been Quality Week, and today is World Quality Day.
Yep.
So,
Well, happy Quality Day and Quality Month, everyone. And it looks like we have a +1 for senior membership. So fantastic. Thank you, Louis. All right. Oh, did I get another message? Oh, someone else said Happy World Quality Day. Yes.
Bob, I have a question for you. This is Barb.
yes.
I understand from Hillary that you were running the leadership team meeting on Tuesday, and I couldn't get into it.
No,
And
I've
Jennifer Kirsten couldn't get into it either.
right.
And
Huh.
I don't know what was going on. I was using the link that was in the agenda that Hillary emailed out. And when I clicked on that link, I kept getting the message, the host is running another meeting.
Hmm.
So I have no idea what was going on.
Yeah, I don't know either. I mean, it's been the same link that we've had all year. So I don't know.
Yeah,
why
and
we're-
I carefully went to the agenda that Hillary sent out,
Yeah.
and
I
don't
tried
know.
links to Bob over and over, and it would not let me in. It just kept saying the meeting was December 3rd, and I couldn't figure that out.
December 3rd.
That's very strange since the meeting was completely rescheduled using a different link.
Hmm.
But yeah, I'm sorry you guys couldn't get in. That's
Yeah.
frustrating.
Well, we'll try to do better next month. That's the first, I think that's the first one we've had all year that something happened with the links.
Yeah, because because every other meeting this year I've been able to get into.
Yeah.
So I don't know. I have this whole string of weird computer problems. A lot of times it's with Zoom, but sometimes it's other things, and it's just like, oh
Yeah.
my goodness,
Yeah.
I must be really dumb.
Yeah.
No, there was some quirk happened somewhere. I mean, we still had 5 or 6 out of the 12 member leaders on the call. So
That's good. That's good. I'm glad that worked out.
worked for some of us.
Yeah, I
Yeah.
don't know.
Well, and someone had Lewis
Someone asked a
was
question.
asking,
Oh, yeah.
have we tried other platforms? And we in the Phoenix section have been doing virtual programs since 2019. So this was well before COVID.
Right.
And we've used a variety of platforms through the years trying to settle on the best user experience. We first dabbled with free conference call, and that worked quite well. But then as our participation grew, we moved to WebEx because ASQ has a WebEx license. However, the feedback from our members is that WebEx is just too complicated to use. And we also heard from some people that, well, if they participate in these meetings from their workplace, because they probably work in a regulated industry like aerospace or healthcare, the only platform their employer allows on their equipment is Teams. But
Okay.
I found
Mhm.
Teams to be quite unstable as well. So right now, Zoom seems to be working the best, although we just recently had a hiccup. But
Yeah.
for most people, they prefer Zoom just because of its ease of use.
Yeah. I've had hiccups with Zoom and other groups too, giving me the same message that you got, Barbara. So I don't know. It's a weird little quirk. It doesn't happen often, but it does sometimes.
Yeah.
Okay.
Yep.
Well, thank you
Right.
everybody who attended tonight, both from the division and from our division and with beyond the section. I want to thank everybody for their continued patronage of the Phoenix section, and please do respond to the survey because in addition to these breakout rooms where we generate ideas for future sessions, we also ask that question with every survey, and we do go through those surveys at every leadership team meeting. And Our
do.
program chair uses those, that feedback to locate speakers on the topics you've expressed an interest in. So certainly want to hear your ideas and thoughts. And if you have any other recommendations for improvement, please keep us up to date.
Yep, absolutely. All right, everyone. Well, it's been fun. We hope that you stay safe, stay healthy, and that you will join us next month. Until then,
Have a happy Thanksgiving.
yes, have a happy
Yeah,
Thanksgiving.
happy Thanksgiving.
It's
Happy
already turkey day.
Oh,
All right. Bye-bye.
Bye.
bye-bye.
Good day.